Hello everyone. Till now I have discussed about transactions. We have seen that transactions are set of operations which are combined together as a single logical unit. We have also seen that transactions follow four properties, which is atomicity, consistency, isolation, and durability. We have also seen that transactions, multiple of them can work in a concurrent fashion. And why do we want to allow concurrency? Because it improves performance, it improves the throughput, and reduces the response time. We also known that when the transactions are working together in an interleaved fashion, the different transactions, a group of them, are called as schedules. In the previous sessions, we have also seen that the schedules which are working as one after another or in a serial fashion, they will always follow the acid property. That means the transaction 1 commits before the transaction 2 starts. That will always follow the acid property. But in real life, we can't ensure that. So what we are checking for in conflict serializability, or the schedules are conflict serializable when the given schedule produces the same result as the schedule which is serial one. To check for conflict serializability, we swap the conflicting instructions, and if the final result is equivalent to a serial schedule, then we will say that the original schedule is conflict serializable. We also know that there are chances in which there are blind writes that may happen. In case of blind writes, still the final result is equivalent to a serial schedule, but the conflict serializability may not be tested. In that point of time, we check that if the schedule is not conflict serializable, that means by the precedence graph we are avoiding, we are not following, or we are not getting that it is conflict serializable, then at that point of time, and there is a blind write, we check for view serializability. That means we check that there is the initial reads are same, the final writes are done by the same transaction, and the intermediate reads are same. Now there is a point of time where we have checked the conflict serializability, we have also checked the view serializability, but there is a parallel concept of recoverability as well. Now recoverability means that again we have some blind, we have dirty reads as well. Dirty read means the data item has been read by one other transaction which is written by some other transaction. Now in that point of time, the first transaction has not committed before the second transaction has read the data item written by the first transaction. So in this scenario, we can see that transaction 6 and transaction 7, transaction 6 has written a data item A which is read by transaction 7, and the transaction 6 has not committed till now. Now if after a point of time the transaction 7 commits and then there is a failure, then because the transaction 6 has not committed, transaction 6 will roll back, and because there was a dirty read and the transaction 7 has committed, it can't roll back, because if it rolls back, then it is violating the durability. If it does not roll back, then it is violating the consistency, because the data item which is read by A was not consistent one, because the transaction 6 has rolled back. Now at that point of time, this schedule is not recoverable. So one of the properties of irrecoverability is that there is a dirty read. But to ensure that the transaction is recoverable, we need to make sure that if the transaction 6 commits before transaction 7 commits, that means the transaction 7 which reads a data item from transaction 6 commits after transaction 6 commits, then it is recoverable. So to ensure recoverability, we need to make sure that the transaction which reads the data item written by some other transaction, that other transaction commits before this transaction. So that will ensure the recoverability. That means here in this scenario, transaction 7 reads the data item written by transaction 6, so transaction 6 must commit before transaction 7 commits. That is important, otherwise the transaction is not recoverable. Okay, what about cascadeless schedule? That means here in this particular scenario, it may be possible that we are following the acid properties, we will be following that the schedule is serializable, but the schedule is failing again and again. Failing again and again means there are dirty reads, but there are multiple set of dirty reads amongst the different set of transactions in the schedule. So here we say that transaction 9 has a dirty read, transaction 10 has a dirty read from transaction 9. So because the transaction 8 aborts because of some failure, the transaction 9 and 10 did not abort, there was no failure, but because they had dirty read in transaction 9 rolls back and aborts, and because transaction 10 has read something from transaction 9, transaction 10 also rolls back. No violation of acid property, nothing, but there is a wastage of time. If it is possible that the rolling back happens once again, or once again the transaction 8 starts and there is a moment in which transaction 9 works, and then a similar fashion transaction 10 works, and again 7 rolls back, then it is a cascading schedule. So we need to avoid that. To avoid the cascading schedule, the problem here is again dirty read, but the problem will not be solved by committing the transaction from which the dirty read is happening. It doesn't happen because the problem is not with the committing. It may still be recoverable, but the problem here is that of dirty read itself. So we need to prevent dirty read. So the solution here is that whatever we are reading or whatever the transaction reads is read from a committed transaction. So transaction 8 has to commit before transaction 9 reads that. I am not again saying that they have to work in parallel fashion. It may be possible that there are set of instructions in transaction 9 on some other data item. But when data item A is working at that point of time, the A is reading from a committed transaction. That's it. Still, it can work in a concurrent fashion, but the reading need to happen in a from a committed transaction. So again, it is not an absolute must property. Absolute must property is asset property itself. But if we are having if it is a desirable property, I can say that, but not a must property. Desirable property of cascadeless schedules as well. So here we have seen the transactions, we have seen the schedules, we have seen that there is a conflict serializability. We have also seen that there is a view serializability, view serializable schedule. The two other important properties we also saw was is the schedule recoverable, is the schedule cascadeless or not. Thank you very much for your time.